real, and equal. So your IC is equivalent now to e raised to negative 2t times C1 plus C2 times t. This is in terms of amperes. So therefore, the transient expression of I is e raised to negative 2t times C1 plus C2 times t plus your IP plus e raised to negative 40 amperes. Okay? That is not your I, rather. This is your Q. Okay? Yan. And to determine the value of C1 and C2, it will follow the same procedure as we have done in our first examples. Okay? So how do we find your Q in any of the equations that we have here? Okay. So at time t is equal to 0, we have the initial value of V and initial value of I. So if we try to have your KCL or your initial conditions rather at time t is equal to 0 at point x, you will be getting 8 e raised to negative 2t is equivalent to I plus derivative of q with respect to t. So at time t is equal to 0, this is 8 is equivalent to I, that is 2, plus derivative of q with respect to t. So you will now have the derivative of q with respect to t being 6 coulombs per second. Okay, let's have your dq all over dt, that is equivalent to 6. First is, we need to have your q at time t is equal to 0. Okay. Also, at time t is equal to 0, your V is 6 volts. That is Q all over C. So 6 volts is equivalent to Q all over the capacitance of 1 over 8. That is 8Q. 6. So Q at time t is equal to 0 is 6 over 8, or that is 3/4. 0.75 coulombs. So your Q at time t is equal to 0 is 0.75. Okay? So making use of these conditions now, at time t is equal to 0, the initial value of Q is 0.75 coulombs. So we will now have 0.75 is equivalent to e raised to negative 2 times 0, C1 plus C2 times 0 plus e raised to negative 4 times 0. This is 1. This is also 1. So this is negative 0.25. Okay, is equivalent to C1. So therefore, C1 is negative 0.25. Okay. Next, we need to have the derivative of Q with respect to T from this equation. Okay, let's try to write down our general equation. Q is e raised to negative 2t negative 0.25 plus C2 times t plus e raised to negative 40. Okay. Let's try to erase this again. First is, let us try to expand this. So Q is negative 0.25 e raised to negative 2t plus C2 times t e raised to negative 2t plus e raised to negative 40. Okay. So the derivative of q with respect to t is negative 0.5 e raised to negative 2t plus c2 times, okay, first term times the second term plus the first term times the second term, derivative the second term, minus 4e raised to negative 40. Then we make use of these initial conditions that at t is equal to 0, derivative of q with respect to t is 6 coulombs per second. So this is 6 is negative 0.5 plus C2, okay, 1 plus 0 minus 4, correct? So this is 5.5 is C2 minus 4. So C2 is equivalent to 9.5. So therefore, we now have the transient expression of Q. Q is equivalent to E raised to negative 2t negative 0.25 plus 9.5 times t plus E raised to negative 40 columns. And once you have your Q, it will be very easy to obtain your I. Okay? You needed only to obtain or make use of this equation. But first, let us have this one distributed. Negative 0.25 e raised to negative 2t plus 9.5 times t e raised to negative 2t plus e raised to negative 40. That is your Q. And we need to obtain the first derivative of this. Okay. Derivative of Q with respect to t is equivalent to 0.5 e raised to negative 2t plus 9.5 times 1 e raised to negative 2t plus t times negative 2 e raised to negative 2t. Okay. Plus yan, tapos na to, minus 4 e raised to negative 40. Then if we try to simplify, that is 0.5 e raised to negative 2t plus 9.5 e raised to negative 2t minus 19, correct? 19 times t e raised to negative 2t minus 4 e raised to negative 40. Okay, we can combine these terms to obtain the derivative of q with respect to t, that is 10 e raised to negative 2t minus 4 e raised to negative 40. So this is I is equivalent to 8 e raised to negative 2t minus 10 e raised to negative 2t minus 4 e raised to negative 40 minus 19 times t e raised to negative 2t. So your I is 8 e raised to negative 2t minus 10 e raised to negative 2t plus 4 e raised to negative 40 plus 19 times t e raised to negative 2t. So if you combine similar terms, your final equation now is negative 2 e raised to negative 2t plus 4 e raised to negative 40 plus 19 times t e raised to negative 2t amperes. Okay? And you can always check the validity of this equation, whether it is correct or not. One of the ways so that you can check this one is you apply the initial conditions in the problem. Meaning, at time t is equal to 0, you should be getting a value of 2 amperes. So at time t is equal to 0, this quantity will become 0. This is 1, negative 2 plus 4, you will get your 2 amperes. That is one way on how to validate whether the transient expression of I that you obtain is correct. Okay? And now, the most common problem here is, it's not the subject that we have is the problem, but rather the underlying and connected subject into it. Your differential equations, just like this one. You can also try, just like what we did, that, or I have advised you previously last time, to also study your Laplace transforms. Okay? Laplace transforms is an alternative to differential equation with the same result. Okay?